We've been working with trig functions of angles located on the coordinate plane. Today we're going to move those off of the coordinate plane and look at the right triangle-based definitions of these same functions. The first thing that we need to do is identify the major components of the right triangle that we'll be working with. So there's our triangle here. Please note the right angle is almost always labeled capital C. The acute angles are A and B. The way that we've been using this, we've called the base the x value because it's the distance along the x axis. The altitude has been called the y value because it's the distance along the y-axis. And then we have called the line, or the ray rather, r, which actually stands for radius. And we'll talk more about that when we get to chapter 6. When we're taking a right triangle off of the coordinate plane, we change the names of these values. We usually call the altitude lowercase a. Please note that it is across from angle A. Similarly, the base we call lowercase b because it is across from capital B. And the hypotenuse we call lowercase c, and it is across from capital C. Now, right now I'm using the word across from. The correct terminology is opposite. Opposite means across from. So, side A is opposite angle A. Side B is opposite angle B. Side C is opposite angle C. We can also reference these as adjacent. And adjacent means next to. Side B is adjacent to angle A. We never reference a side as being adjacent to the right angle. We never reference the hypotenuse as being adjacent to either of the acute angles. The hypotenuse is the hypotenuse, that's all it ever is. The right angle is the right angle, that's all it ever is. A and B are the ones that can change. A is opposite angle A, adjacent to angle B. B is opposite angle B, adjacent to angle A. When we talk about the trig functions on right angles, we use the acronym SOHCAHTOA. It talks about the fact that the sine of an angle is the opposite side over the hypotenuse. The cosine of an angle is the adjacent side divided by the hypotenuse. And the tangent of an angle is the opposite side divided by the adjacent side. So if I use this particular triangle, I could take the sine of angle A. It's the side opposite of A divided by the hypotenuse. Well, opposite of A is lowercase a. The hypotenuse is lowercase c. The cosine of angle A is the side adjacent to A divided by the hypotenuse. So cosine would be B over C. And if I did the tangent of A, we would take the side opposite of A, divided by the side adjacent to A. And that would give us A over B. I can do the same thing with angle B. The sine of B is the side opposite divided by the hypotenuse, which makes this b over c. The cosine of b is the side adjacent divided by the hypotenuse, which makes that a over c, and the tangent of angle B would be the side opposite divided by the side adjacent. We know what sine, cosine, and tangent are for a 90-degree angle, so we actually don't need to use SOHCAHTOA to find anything for the right angle. You should recognize that on a right triangle, angle A and angle B are complementary. Remember that the total sum of the angles of a triangle is 180 degrees. C is given to us at 90, which means that A and B have to add up to equal 90. Well, something that is important to recognize with regard to these trig ratios is what happens when we start taking the ratios of the complementary angles. Take a look at the sine of A. The ratio for sine of A is A over C. A over C is also the ratio for the cosine of B. These are called cofunctions. It means that the sine of one angle is the same as the cosine of that angle's complement. Here, the cosine of A is B over C. B over C also represents the sine of B. These cofunctions are also true for tangent and cotangent, secant and cosecant. So if you took the tangent of A, that would be the same as taking the cotangent of B. Another way we write that is that the tangent of A is equal to the cotangent of 90 minus A. Next, we'll look at special right triangles. You should have worked with these in geometry. They've come back to haunt us. What we'll do is we'll start with an equilateral triangle. Remember that equilateral means that all the sides and all the angles are the same, which means that the angles are all 60 degrees. The sides can be any measurement. We are going to assign the value 2 to the side length of this equilateral triangle. The next thing that we'll do is we'll bisect one of the angles. We drop an altitude. What we have done is we've created right angle and two separate triangles. This base that was a measure of 2 has now become 2 measures of 1. So now we have two separate right triangles. This is a 30, 60, 90 triangle. We know that the hypotenuse has a value of 2, the base has a value of 1, and we can use Pythagorean theorem to find the value of x. So that's 2 squared is equal to 1 squared plus x squared, and we can solve for x. What we have done is we have now assigned a ratio to this triangle. Please notice the smallest angle is 30 degrees. The smallest side is opposite the smallest angle. The largest side is opposite the right angle. And then the one in the middle, the square root of 3, is opposite the 60-degree angle. That will always be true. The smallest angle will always be opposite the smallest side. The hypotenuse will always be opposite the right angle. Once we have done this, we can assign trig function values to 30-degree and 60-degree angles. So the sine of 30 is opposite over hypotenuse, so that's a half. Cosine tangent that would be square root of 3 over 3. I did this in 2 steps. I made this 1 over the square root of 3, and then I rationalized. The cosecant the secant and the cotangent. I can take those same trig ratios for a 60-degree angle. You should have some method of memorizing these ratios because they come up a lot. The next special triangle that we will look at would be the 45, 45, 90. Now, something that you should definitely notice is that when the two legs of the triangle are equal, that means that the two angles must also be equal. That's incredibly important to pay attention to. And if the angles are equal, then they have to be 45 degrees. So again, we'll use Pythagorean theorem to find the length of r. We could also call it c. So r squared is equal to 1 squared plus 1 squared. So the hypotenuse is the square root of 2. Just like with the 30, 60, 90, we can now learn the trig ratios for a 45-degree angle. So this would be opposite over hypotenuse, which makes this square root of 2 over 2. Notice that the cosine of 45 is equal to the sine of 45. And when we talk about cofunctions, sine and cosine are cofunctions. 45 and 45 are complementary. So cofunctions of complementary angles are equal. Taking a look at the next one, tangent to 45, 1 over 1. We'll take a look at the cosecant. That's 2 over the square root of 2. Remember, we have to rationalize. And that gives us 2 root 2 over 2, which is simply square root of 2. The secant is actually going to be exactly the same. It'll be 2 over the square root of 2. When we rationalize that, we simply get square root of 2. And then again, secant and cosecant are cofunctions. 45 and 45 are complementary. Therefore, cofunctions of complementary angles are equal to each other. Finally, if we look at cotangent, we again get 1 over 1. Tangent and cotangent are cofunctions. 45 and 45 are complementary. So those cofunctions of complementary angles are equal. Here's our first example. We need the sine, cosine, and tangent ratios for angles D and E. So we'll start with angle D. Sine of D is 36/85. I know that 85 is the hypotenuse because it is opposite the right angle. Cosine of D is 77/85, and the tangent of D is 36/77. For angle E, the sine of E will be 77/85. Again, the same as the cosine of its complement. The cosine of E is 36/85, the same as the sine of its complement. Tangent of E will be 77/36. With regard to cofunctions here, we're asked to write each function in terms of its cofunction. So the first one is the sine of 9 degrees. Well, the cofunction of sine is cosine, and I need its complement, which would be 90 minus 9. That makes it cosine of 81 degrees. The next one is the cotangent of 76 degrees. The cofunction of cotangent is tangent, and I need the complement. That makes this the tangent of 14 degrees. And then finally, cosecant of 45 degrees. The cofunction of cosecant is secant. So it would be the secant of 45 degrees. We've actually done a problem like this already, but I'm going to repeat it anyway. We need the 6 trig function values for a 30-degree angle. They're not asking you to put this into your calculator and come up with decimal approximations. They want exact values, which means fractions and radicals. So if you're not sure, if you don't have these memorized, sketch a triangle. So we've got a 30, a 60, and a 90, and the ratio is 1 to square root of 3. So now I've got this laid out, I can write out my 6 trig function values. So this would be 1 over the square root of 3, but I would need to rationalize that, which gives me the square root of 3 over 3. This would be 2 over the square root of 3. Again, we have to rationalize, which gives us 2 square roots of 3 over 3.